All right, today we're going to work on Module 19.5, focusing on congruent figures in this unit of geometric transformations. So today we're going to focus on making connections between the transformations we've already learned about, rotations, reflections, and translations, and kind of putting them all together to see if something is actually congruent. So before we talk about what it means to be congruent, let's go ahead and try this activity where we're actually going to do multiple transformations of the same pre-image to see if we get to a congruent figure by the end. So let's start following along, and I actually wrote rules down for myself to follow from yesterday's lesson. Hopefully you made a list somewhere of the rules for rotation and reflection just like the book had. But I'll go ahead and start. So it says combining transformations. Apply the indicated series, A through E, of transformations to the triangle. Each transformation is applied to the image of the previous transformation, not this original pre-image, right? So whatever I do next, I'll use that image to do the next step. I'll use that new image to do the next one, etc. Label each image with a letter of the transformation applied. Let's try it. So the first thing we have is A, reflect across the x-axis. So now I'm looking at this pre-image to reflect across x means I'm going to have a new image down here in the lower quadrant. And if I'm reflecting across x, the rule yesterday said that I'm going to multiply all my y coordinates by -1. So I'm just going to write these coordinates down. So first I have 5, 2. Then I have 5, 4, and I also have 3, 4. Okay, to make it a little easier for myself, I wrote these coordinates down so that I can now work to reflect. So if I'm reflecting over x, all of my y coordinates are going to be multiplied by -1. So this will become 3, -4. 3, -4. This is for part A, right? So I will have 1, 2, 3, -4, 1, 2, 3, 4. Then this will become 5, -4. So 5, 1, 2, 3, 4. And this will become 5, -2. 5, 2. And I will connect. And it says to label it with the letter of the transformation applied. And in this case, that was A. Okay. And we could have even counted to see how many units it is, each point is away from the axis, and then continued on that way. But I think the easiest is just to follow the rules and kind of get them in your head a little bit better. Let's move on now to part B. This one says reflect, or it just says x minus 3. So that means this is a translation. And then answer out loud to yourself, where do you think this translation is taking us? To the left or to the right? If you said to the left, you are correct, because we have a subtraction of 3, meaning we're going to move away from the positives, more towards the left-hand side of a number line or the grid. So everything is going to move over 3 spaces to the left. So we'll start with this point, 1, 2, 3. We'll start with this point now, 1, 2, 3, and this point, 1, 2, 3. And we'll draw our new image and label it with the transformation, which is B. Should continue to be the same size, same shape. All that moved is location. Part C says reflection across the y-axis. So now I'm going to use this image to reflect across y. So if I reflect across y, that means all of my x coordinates are going to be multiplied by -1. So I'll write these coordinates down so that I could use them for part B. I have 0, -4. Then I have 2, -4. And then I have 2, -2. And it says if I'm reflecting across the y-axis, the rule is that I'm going to go ahead and multiply every x coordinate by -1. So 0 times -1 is still 0, and -4 stays the same. 2 times -1 is -2. -4 stays the same. And 2 times -1 is -2. and the negative 2 stays the same. So let's plot these. Obviously, I have an overlapping coordinate. Then I have negative 2, negative 4. And then I have negative 2, negative 2. And I will connect and label it with the transformation C. Okay, so far so good. Now it's asking me for part D. It says y plus 4. This is a translation because I'm adding. Translation where, though? Is it left, right, up, or down? And if you're saying up, you are correct, because now I'm on the y-axis, which moves up and down vertically. And if I'm adding 4, that means I'm going to move up. So all of these points are just going to move up, each of them. I'll start here with this one. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And I'll draw my new image, and I will label it D. That's perfect, okay? Now the last one says for part E, rotation 90 degrees clockwise around the origin. I am on the origin, which is perfect. Now it's asking me to rotate 90 clockwise. Okay, clockwise is gonna be in this direction, right? 90 degrees. So I'll go ahead and use the rule of 90 degrees clockwise that says when I'm rotating 90 degrees clockwise, I'm going to multiply all of my x coordinates by negative 1. And then I'm going to flip them. So I'll write up here for letter E. My new coordinates are 0, 0, negative 2, 0, and negative 2, 2. Those are the coordinates on this image where we are now. For part D, we want to change for part E a 90-degree clockwise rotation, so I'm going to multiply all of the x's by negative 1. And then flip. So for now, let's just do times negative 1. So 0 times negative 1 is still 0, so 0, 0 stays the same. Negative 2 times negative 1 is 2, and the 0 stays the same. And negative 2 times negative 1 is 2, and the 2 stays the same. But now it's asking me to flip. This is where I flip. 0, 0 stays the same. This becomes 0, 2, and this becomes 2, 2, which stays the same. Let's see if that actually works out to give us a 90-degree rotation, same size figure. So we did it right. 0, 0 stays the same. Then I have 0, 2. And then I have 2. 2, 2. Sorry, I thought I was making a square for a second. Okay. And this is part E. Okay, so you just took this through 5 transformations. It's asking us to compare the size and shape of the final image to that of the original image. Let's see. Is the size of part E the same as the pre-image? I have 2 units as one length, 2 units as another, 2, 2. And then I cut across 2 units. So the size right now is the same. The shape is also the same. I also have a triangle and triangle. So let's say yes, the size and shape are the same. What's the only thing that's different? Tell yourself. If you're telling yourself that the only thing different is the location or orientation, you are correct, okay? Orientation is like which way it's facing. Right now we could say that this length is facing, this side is facing towards the right, this side is facing towards the left, right? It kind of flipped it to an orientation, to a different orientation. So now let's see if that works with congruent figures. If we turn the page, it tells us what a congruent figure is. Recall that the segments in their images have the same length and angles, and their images have the same measure and under a translation, reflection, or rotation. 2 figures are said to be congruent if one can be obtained from the other by a sequence of translations, reflections, and rotations. Congruent figures have the same size and same shape. Since these had the same size and same shape, these are congruent. I also took it through a rotation, a reflection, 2 of them, and 2 translations, meaning we definitely tested to see if they were congruent. Can't just look at it and say they are. Let's see here in this example. Identify a sequence of transformation that will transform figure A into figure B. So now I kind of have to say, how do I go from figure A, here, to figure B? What are the translations I need to do? But it has to be a sequence. Can't just be one. So to transform figure A into B, you need to reflect it over the y-axis and translate 1 unit to the left. A sequence of transformations that will accomplish this is multiplying your x's by -1 and then subtracting 1 from x as well to move it over. So this is a sequence. Identify a sequence that will transform figure B into figure C. Any sequence of transformations that changes figure B into C will need to include a rotation, obviously because it's oriented in the wrong way. A 90-degree counterclockwise rotation around the origin would result in the figure being oriented as figure C. So if I take this figure and I move it over 90 degrees counterclockwise in this direction, I will get back to C. However, the rotated figure would be 2 units below and 1 unit to the left of where figure C is. So I'm going to also need to translate the figure 2 units and write 1 unit. So this is also a sequence because I have more than just a translation or more than just a rotation. I have more than one transformation that I'm doing. Let's put that into practice. Okay, let's take a look at figure C. Identify a sequence of transformations that will transform figure D into figure E. So take it from here to here. Well, I definitely know there's going to be some sort of rotation, right? Because I see that this is horizontally laid out and this is vertically laid out. So I am going to need to do a 90-degree clockwise rotation. And the origin would result in the figure being oriented as figure E. However, we would be in this quadrant, so we would need to move 90 degrees clockwise to get it to this quadrant, and then we would need to do a translation to move it down, okay, 6 units. So let's see how I would get to to number 3 here. Identify a sequence of transformations that will transform figure A into figure B. So moving from A to B. Why don't you guys try and see what you come up with? If you want to pause the video and try on your own and then come back. Otherwise, we'll continue on together. Identify a sequence of transformations that will change A into B. The first thing I might want to do is rotate 90 degrees clockwise. Okay, if I rotate A 90 degrees clockwise, that means I'm going to multiply, because I want to get it into this quadrant, right? That's my goal. I need to get here to move here. So I will do 90-degree clockwise rotation, which means I'm going to multiply x by -1. So I'll use all of these coordinates. Let's see. Right now I have -2, 2. I have -2, 5. And I have -4, 5. So I'm going to multiply all of my x's by -1, which would get me 2, 2. -2 times -1 is 2, 5. -4 times -1 is 4, 5. But I also now, if you remember, need to flip. These are the rules, right? So I'll flip this to be the same. I'll flip this coordinate to be 5, 2, and this one to 5, 4. Let's graph that new triangle that we put into this quadrant so that we're able to now move on. So 2, 2, 5, 2, 5, 4. This looks good. Okay, so the first thing I did was rotate 90 degrees clockwise about the origin. Okay? Now what? The best thing I could do now is transform it to translate down, because we see that it's the same size, same shape, just separate locations, so different quadrants, so I need to translate down. How many units down? Let's see. From this point to this bottom base, right, the bottom base to the bottom base, I have 1, 2, 3, 4, 5 units. So I am going to translate everything down 5 units, which means translate 5 units down. And if I do that, I am going to end up here where triangle B is located. How do I write that though algebraically? So the first thing I want to do is change x and y, the originals, by rotating 90 degree clockwise. What's the rule we used? We used multiply everything multiply x by -1, right? And flip. So the y would be here on this side and the -x on this side. And this isn't to say that all of your x coordinates will be negative. This is saying we're multiplying x's by the -1. And the second thing we did was take our x and y coordinates and translate 5 units down. So since I'm translating down, is that my x-axis or my y-axis that's being affected? Hopefully you're saying y. Our x units are going to stay the same, but what we did was do y minus 5. Every y minus 5 to get to this point. Sounds really complicated. However, if you take it step by step, look at those algebraic rules from yesterday's lesson and actually try to work it out by writing out coordinates and doing some of the math as opposed to figuring it out in your head and drawing it down, I think you'll be okay. You'll do better than okay. You'll do great. So take your time. If you need to, write a messy set of rules to have by your side to tell you what you need to do for rotations and reflections, or write it more neatly, please, and then use that to help you. Because on your homework, what you're going to have to do is let us know for each given figure of A, you're going to graph figures B and C using a sequence of transformation. So it'll tell you, what do I do to make figure B? And then from B to C. Same thing on all of them, okay? And then you're going to get to congruent figures. So on your homework, you're going to do problems 7, 8, 9, and 10. Okay, take your time, complete your exit slip, you'll do great.